Are you ready, kids? 10.3 shapes of distributions. I know you're probably sitting there going, I don't know what that means. Well, by the end of this, hopefully you will. The essential question, how do I describe the shape of a distribution on a histogram? Okay, how do I describe the shape of a distribution on the histogram? So these are the kinds of words we're going to be looking for, like describe. When it says to describe the shape of a distribution, we're going to be looking at the key idea here. This is going to help us answer that question. Symmetric and skewed distributions. Okay, it looks like we have 3 columns here, and we're going to start in the one in the middle, which is symmetric. I don't know if you all know this, but if you have something is symmetrical, it means that there is an axis of symmetry, which means if I drew I'm not going to do it great here, but I'll do my best. If I drew a dashed line right down the middle of this histogram, it looks like we have a histogram here. The left side is a mirror image of the right side, or I should say the left side is a reflection of the right side. And so it's symmetric. It's like a human face or so many things that you see that are symmetrical. And so that means that the left side of the graph, I don't know why they call it a graph, but it's a mirror image of the right side of the graph. So if you were to be asked, describe the shape of this distribution, you would say symmetric. This is a symmetrical distribution. And what we kind of have here, hopefully you remember some of this, is that on the x-axis here, you have intervals, right? You have intervals. And then for each interval, you have a certain number of data. And that certain number of data is the frequency, right? So oftentimes we have the frequency, how many times something happens here on the y-axis. So you can see that most of the data are in this interval here, right? And you have less on either side of it. Okay, but what about these shapes? You can see that this is not symmetrical. Could I draw a line right down the middle, and would the left side be a reflection of the right side? No, because if you look at these data, they're way lower than this, right? Except for this one. So this is something that's different. And in fact, this is called skewed left. If you were to be asked, what is the shape of this distribution, you would say skewed left. And the way that I think of it is I think of it as a slide. Like if you're a kid, you have to climb a ladder and then you slide down the slide. And you'd be sliding down to the left. So this is skewed left. Skewed just means not symmetrical. And this says the tail of the graph extends to the left. So if you think of this as the head and maybe the wings of a bird or something, and then you have the tail out to here. So the tail's out to the left. And most of the data are on the right side. Despite this interval having a pretty low frequency, as you can see, most of the data are here. That's where most of the frequency happens, right? So you have these intervals, you have a lot of data here, less data on this side. And if that's skewed left, you climb the ladder, you slide down the slide, and this one you slide to the right. Skewed right. What does skewed mean again? Were you paying attention? Skewed means not symmetrical, right? Or not symmetric. And the tail of a skewed right graph extends to the right. Well, would you look at that? You have the head of the bird here, and you have a wing here from this above view, I guess. And then it goes down to the tail. Personally, I like my slide idea. You can leave it in the comments. Tell me whether you prefer the bird or the slide. I like the slide. Most of the data are on the left. So you can see that on a skewed right, most of the data are concentrated on the opposite side, on the left. For skewed left, most of the data is concentrated on the right. For symmetric, most of the data is where? Right in the middle. Okay, so if we're asked to describe the shape of a distribution, we're going to use one of those 3 descriptions. Let's do this. Okay, question. How do I identify the shape of a distribution? Describe the shape of each distribution then. Okay, let's start with part A. This says daily snowfall amounts. Oh, snowfall. We haven't had snow here in a long time. I think the last time it snowed in Yorba Linda was 1961. But anyways, looks like they have, do you remember what this is? It's a data display. It's not a histogram. It's one of the other ones we've learned about. It's got a lot of dots. It's a dot plot. Yes, it's a dot plot. Very good if you actually knew that. Now let's look at the shape of this. Where are the data concentrated? Are they further to the left? Is it further towards less snowfall or further towards greater snowfall? Hopefully you see most of the data are over here to the left, which means this is skewed right. This is skewed right. And I'll show you another way, skewed right, to determine that. Hopefully you see it. It's the slide method, right? If you climb the ladder of the slide, you would slide down to the right, right? So this is skewed right. And the important thing here is that most of the data are on the left. What about this data display? Can you identify it? It has 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69. Those are intervals because they're all the same size. They're all 10. They all include 10 different numbers of passes. And the frequency, of course, is how many times how many data points you have in that interval. So 0 to 9, including 0 to 9, we had, it looks like just 1. 10 to 19 looks like we had 5. And you can see 30 to 39 looks like we had 15. What is the shape of this distribution? Because we're supposed to describe the shape. Could I draw a line of symmetry down the middle? And is the left side roughly a reflection of the right side? Yes, it's not perfect, but it's close. It's close enough to say that symmetric is the best description of the shape of the data. So this is a symmetric data set. All right, that ends part 1 of this video. I'm going to be back with part 2 in just a short moment.